Hello and welcome to Excellent Link Academy. For today, we'll try to discuss about the exponential function of differentiation. But today, we'll be basically looking at the shortcut involving exponential function of differentiation. So I'll drop the link to how to differentiate them using exponential function. But today we'll consider the shortcut. So check the description of this video. You'll see a link there that'll take you to our first class on the concept of exponential function of differentiation. But for teaching's sake, I'll try to solve a problem using the idea of our last class. So let's say that, example, let's say that if I have that y is equal to exponential x squared, and I'm told to find the y by the x here, what do? The task is quite simple. Look up. I know very well that I'm differentiating y with respect to x. I am differentiating y with what? Respect to x. It means that I'll have the y by the x. But in this case, look up, when it comes to exponential function, the task changes. The first task is to call this one, the term here, this one here, call it u. So let u be the part. So let u to be equal to what? X squared. That's the first task. If you call u to be x squared, so it means that I'm differentiating u with what? Respect to x. So I'll have the u over x to be equal to, from the idea of general method of differentiation, if I differentiate x squared, I'll have what there? 2x. I'll have 2x from the idea of general method of differentiation, right? So proceeding at this point here, your first task, call the term here, call it u. Differentiate with respect to u, I'll have this. At this point here now, we just said that y is equal to exponential x squared. This is x squared, but we just said x squared should be what? Should be u. So I'll put u here. So it means that I am differentiating, observe now, I'm differentiating y with respect to what? U in this case. That becomes dy over the u to be equal to, if I differentiate exponential x, from what we know generally, that if I have that y is equal to exponential x, dy over the x is what? Exponential x, right? So it means that if I have y to be equal to exponential u, it means that the y value is what? Exponential u. From here now, I'll apply the concept of chain rule. So using chain rule, from the concept of chain rule, what do we know? We know that chain rule says that dy over the x is equal to what? Dy over the u times the u over the x. At this point here, let's put in value to get rid of the x. So the y over the x, which is this, the y over the x is now equal in value to the y over the u. The y over the u is what? Exponential u. I'll have exponential u. Multiply that the y over the x, which is this, is equal to exponential u as my the y over the x u. So the u over the x, check. The u over x is what? 2x multiplied by 2x. It means that multiply these two, I'll have that the y over the x is equal to 2x exponential u. So observe that I'm having the y over the x. Look up, I'm having the y over the x. It means that anything here must be in terms of x. I can see x here. I'm having the y over the x, I'm seeing x, this is u. So if this is that I was having the y over the u, then I will expect u here. So I'm having the y over the x, I'm expecting x here. So this is x, no problem. But this is u. I need to take this u back to x. At this point now, but u was equal to, we said u was what? X squared. So it means that dy over the x is equal to what? 2x exponential. What's u? X squared. X squared. Like the idea behind how to solve problem using exponential function of differentiation. But let's now dive into the shortcut. When we say the shortcut, instead of passing through this process, this long process, there's a shortcut to it. Now look, when it comes to shortcut, here's what you need to note. Your first task is to pick out the index, or perhaps the par, or you call it the degree. Pick out the index. Next up, differentiate the index and attach it to the question, or perhaps the function, as you want to call it. So it means what I'm trying to say is that, let's say I have that y is equal to exponential x squared. Let's apply shortcut here. What is shortcut? We said that for here now, have that the y over the x is now equal to, the shortcut is what? We said differentiate the par, right? If I differentiate x squared, I'll have what? I'll have 2x. Next up, repeat the function or the question, as you want to call it. So I'll repeat this one here, exponential x squared. That's all. Observe that this and this are the same. That's all. It's like a shortcut to solve problem under exponential function of differentiation. We'll take several examples to further explain this. Example 2. Alright, example 2. How that's example 2? Let's say I have that y is equal to exponential 4x squared plus 3. As in this case here, I'm told to solve this. So instead of wasting my time, let's apply shortcut. Applying shortcut is quite simple. First task is to differentiate the part. So I'll have that the y over the x is now equal to differentiate 4x squared plus 3. I'll have 8x, right? Next up, repeat the function, or perhaps repeat the question, exponential 4x squared plus 3. This is my answer here after differentiating it. So observe the idea behind the shortcut of exponential function. Your task is that pick out the par first. Next up, after picking out the par, differentiate that par. So I have this. After differentiating this one, I have this. Repeat the function, or perhaps we call it repeat the question. I have this. So like shortcut. Let's take one more example to explain this concept here. Let's say I have that y, example 3. Let's say I have that y is equal to let's say that y is equal to exponential 4x plus 3 all to power 3, as in this case. Now look up. We said to differentiate this is quite simple, right? What's the first task? Differentiate the part. That's a shortcut to a special function. Differentiate the part. So I'll have that the y over the x is equal to differentiate this part. Observe that this part I want to differentiate is not just an ordinary part. It's a question on chain rule, right? This is a chain rule, right? So this is a chain rule. So it means that I'll try to drop the link on how to solve chain rule shortcuts in the description of this video. So check the video, check the link on how to solve problem under chain rule, perhaps the shortcut using the idea here. So it means that to solve this one using shortcuts for chain rule, our first task is that right at the par, I have 3. Differentiate them in brackets, I have 4. Repeat the question, 4x plus 3. Subtract from 3, I have 2. This is like the idea behind chain rule shortcuts. So I'll drop the link in the description of this video. Alright, now your first task is what? Differentiate the part, as I did here. Next up, repeat the question. What's the question there? Exponential 4x plus 3 all to power 3. So for number here, let's simplify this more better. So the y over the x is now equal to 3 times 4 is what? 12. I have 12. Next up, into 4x plus 3 all squared. Exponential what? 4x plus 3 all to power 3. You can also, this is my final answer here. You can also choose to solve it this way. right? You still have the same answer as we did here, right? So you still have the same answer as we did here. So this is how to solve problem using the idea of general shortcuts. See you in the next class.